So we've got a list 1, list 2. Now, I didn't tell you which one had to be in list 1, list 2, but it would make sense to do the first one in list 1 and the second one in list 2. I would imagine these are fake numbers. Those are, I mean, I get that football players are larger, but those are still really, really high for football players too. What? And also pro football players' weights, they have a set weight for them. And if they go over it, like if their set weight is 205 pounds, I think it depends on the team, but some teams do they have to pay $500 for every pound that they're over every day that they weigh in. Like if you're 5 pounds over, then you go $2,500. But I guess it's a team by team thing. So construct a confidence interval for the true difference of the mean weight of pro football and basketball players. So we've got our different values typed in already. So let's go basic to start with. Let's figure out information from our calculators. Let's not figure out information from our calculators. Let's just write stuff. In do, what's the first thing I should... I want to specify, I don't need to write this down. We can be okay with this. I have 2 mu's. I don't want to call them mu1 and mu2. What would make more sense for this problem? Uf and ub. So pretending I wrote that before and actually specified, I think you're okay with that. So here, where do I start? So I'm going to, because, which one was first? Football? So I'm going to call this one X bar F. I'm just writing out symbols right now. I'm going to have, what else? What else? What else with F? Because it's S. And I'm saving myself room to write these in. So maybe I should need a little bit more space. And then I'm going to do the same thing with all of them with B. There's a reason I'm not actually looking them up yet. And then what else do I need? What is our confidence level for this problem? And I'm going to stop right there. I'm not going to write my T or Z right now. Is it T or is it Z? I might write T and then not write anything beside it. And I'll explain why. All right, so let's go ahead and go straight into, now let's write our generic equation. Oh. What do I start with my correct symbol letters? X bar what? And I always do that just showing that it used to be 1. The parentheses really don't matter. Then what? Then what? Of over what in between? If we're doing the difference and we're subtracting this sample from this sample, why is there a plus in between? This goes back chapters where I was talking about how we got this in the first place. You always have to add variances, yes. So then this is what? Now, yesterday, the day before, up until now, I've made you fill in the numbers here, write it generic, and then fill in the numbers in the equation. There's a reason that right now I'm letting you just do this and the numbers written out and then straight to my answer, and I'll show you why. So letting our calculator do this for us, let's go to our test and see what our options are. So where do I start? I know that the beginning is going to have to start with what? So it's going to start with 2. Now this is where people get confused a little bit. Some of them say 2 sample, some of them say 2 what? Proportion. So the prop means proportion. The sample doesn't just mean sample. It means that we're dealing with means. It means it's not proportion. What's it going to end with? Interval. So which number is correct? Is this one Z or T? T. So what's the correct one? So it should be 0 right here. Now, I have 2 options up top. I have data and stats. If I wanted to go in and figure out what all of my different X bars and S's are, I would type in stats. But I already have it all in my calculator already, so there's no reason to do that. So right now I have my list 1 is L1. That's my first one. My list 2 is L2. Frequency, you leave at 1. My confidence level is 0.95. For our class, we do not deal with pooled with means. We only deal with pooled with proportions. So just put no always for right now. And then calculate. And this is why I didn't go and calculate anything myself, is because it does everything for us. So now that I've written everything out here, I'm actually just going to go back in and write in my numbers once instead of writing it in the whole equation. So what is my X bar F? I got 9 something.
259.60.
What is our, I'll skip to SF, is what?
12.46.
And usually I do 4, I'm going to, just for the sake of notes, because I've been doing 4 decimals, I'm going to do that. So 6190, you don't have to write it all out. 12.0560. My second X bar is 205.7895. My second S is 12.8995. My sample size for my football is 21. My sample size for basketball is 19. So if I do this very, very well labeled and write out my entire equation very well labeled, then I don't technically need to fill them in an equation. Now, if you do something wrong here or it's not well labeled, I'll also count off for you not having this, because that means you can't make the connection to get there. But then we also know our answer. Our answer is what on the left side? What symbol comes right after that? I'll come back to that. And then our upper is 61.853. What goes in the middle? Which is what we specified initially. So here, let's think through this one. It never told me what my T was, but it used a T, right? How did I say that you would use degrees of freedom if you do it by hand? Which degrees of freedom would you use? So I would use this, and my degrees of freedom would be what? 18. If you do that and get a T, you're going to get something very slightly different than this. And that is fine to do that and do it by hand. But if you're going to use these numbers, I don't want these to contradict themselves, so I don't want you to write anything down. It technically gives you the degrees of freedom, which is 36.9327. Well, that's nothing like anything that we use. So I just don't want you to write anything with degrees of freedom or what the T value is. Just use your calculator or do the whole thing by hand and not use the calculator.
So is that what you're going to put, like, maybe?
Yeah. And so I just write this. So I show the grader that I know that it's a T, I just don't write with a T after it. So. Z does the exact same way. I'm making sure that I'm right with that though. Oh wait, no. Z, yes. Z is always Z. Z doesn't change. I'm thinking through it. So you could write Z. But I'm not gonna like count off if you don't write T and then you don't write Z. It's like you could write it, you wouldn't get cut off, but I'm not gonna count off if you don't. Questions with this problem? Yes.
Should we add like that, the little interval part at the bottom, should we add that to like the generic voice of process? Like lower.
That's probably not a bad idea.
Yeah.
This part right here. In do, let's add lower, less than or equal to mu1 minus mu2, less than or equal to upper. Yes, I definitely think that'll be helpful. I'm glad you said that. Anything else like that, especially that I forgot to write down that would be helpful? Now with this one, if we were talking through it, what would I say for random? I can say one sentence to say stated that both the pro football and basketball players were randomly selected. Then I could go straight to normal, and I added this part in here. Stated that both the weight distributions of pro football players and pro basketball players are fairly normal, so we can use normal approximation. And then with independent, I would have to say there are at least how many pro football players? 210, and there are at least 190 pro basketball players, which would check off both of our 10% conditions.